We want to practice taking the derivative via the long way, the formal definition. Now, as I said in the notes, this isn't something you're going to have to do a lot of, but you need to be aware of the formula, you need to be aware of how it works, and you want the skills that go along with doing it, because this is great algebra building skills. So there's lots of reasons for why we're doing this way. Not that you're going to spend a lot of time doing this method, which as you get through the problems, you're going to be thankful. But at the same time, there's lots of good skills that we're working on, as well as understanding the basic idea of where this comes from is very important. Okay, so we're going to start by writing down what is the definition, which is the limit as h approaches 0 of, remember, this difference quotient that we've learned, and it's put in a lot of algebra books for this reason too, as something to work with. And you can see it's really just a variation slope, right? It's the change in y over the change in x. In this case, x is this x as it's going smaller and smaller to 0. But it's still the same idea here, is we've got this change that we're evaluating. So now when we come in here, I'm going to start by putting in my function. So I have the limit as h approaches 0 of x plus h over x plus h plus 2 minus, I was getting so excited about all my things, all over h. So you can see here, this right here goes with this. This piece is this one right here. And the other thing to pay attention to is that there is a negative sign here in the middle. Don't forget that the negative, otherwise you're going to be like, why aren't things canceling like she promised they would? Well, it's because you forgot the negative. Okay? So, as I look at this, I just want to go down a little bit. What you're going to notice about this is a fraction within a fraction. It's what they called improper fractions. You probably had to do them back in algebra. And what we want to do is, right now I've got nested fractions, right? I got 3 levels of fractions. This looks awful. So I'm going to start by clearing them. How do you clear fractions? You multiply by the denominator. So I'm going to multiply both top and bottom by both denominators. Okay, so all this is here is both denominators. So then that way here, when I multiply this through right here, this is going to cancel this out. So I have the limit as h approaches 0. I have the x plus h from the numerator times what's left in the denominator. And then here, don't forget my negative, I have the x from the numerator. And then here, this one's going to cancel this one. So I'm left with x plus h plus 2. And then in the bottom, I have it all. Okay? You might think, I don't know, that looks any better. I promise you it is better, because at least it's only, 2 levels, right? It's not 3 levels. We don't want tri-level. Okay, so we have made an improvement, even if it doesn't necessarily look like we have. Now what we want to do is we want to FOIL everything out, distribute everything. So here I'm going to get the limit as h approaches 0. X squared plus hx plus 2x plus 2h minus h squared minus, remember to distribute that negative with it, all over. Okay, now we're going to go through, and we're going to look, and we're going to hope a lot of things cancel, and I promise you they will here. Okay, so let's see here. Those two cancel. Those two cancel. And those two cancel. They don't look exactly alike, but remember, multiplication commutative, so hx is the same as xh. So that did. So I have the limit of h as approaches 0 of 2h over h, x plus h plus 2, x plus 2. Ooh, now all I have is this, so this and this cancel. So now I have 2 over x plus h plus 2, x plus 2. Ooh, this is looking promising, right? I'm like, finally, maybe I'm getting somewhere. Okay, now I can apply this limit. So this goes to 0. It's the only h in there. So then I'm left with 2 over x plus 2, x plus 2, which is 2 over x plus 2 squared. So this is the derivative. So this is my slope of the original curve. This is what, if I put in a number, it'd give me the slope at that instant point. So a lot of work, a lot of good algebra skills, but we want to practice with this formula this week so that we understand the basics of where it's coming from as we continue to learn more and more shortcuts. Don't worry, there's more shortcuts coming. I've seldom had to use this to take a derivative other than the basics, but there's plenty of other reasons we want this basic concept there, so we want to make sure we've got some idea of what's going on with it, and then we'll go back to all those wonderful shortcuts that make our lives so much better. But again, and I've said this before, make sure this algebra is coming easily to you. It is tedious. You have to be paying attention. Neatness counts. And I'm not the poster child here, especially on this, but make sure you're doing that.